So for this problem, we're saying that theta is in quadrant 2 and sine of theta is equal to 2/3, and we want to find the 6 trig function values of theta. To do this, we need to first start by constructing a triangle. We know that this triangle will be in quadrant 2 because our theta value is in quadrant 2. So if we draw our angle theta, it's going to be something like this. And remember, whenever you're finding a reference angle for your right triangle, you always connect to the closest x-axis. It's very critical. Never connect to the y. Always connect to the x-axis like so. And then create your right angle. And from here, we can say that this is our reference angle theta to our original angle. We don't need to know what theta is. We don't need to know what this reference is. We just need the 6 trig function values of that original angle theta that we've drawn here. So we were told sine of theta is equal to 2/3. Remember, sine is equal to y divided by r. So this ratio of y over r is 2/3. So 2 can represent the y value of the triangle, and 3 can represent the r value of the triangle, leaving us with one side left, which we can solve with the Pythagorean theorem. We have r squared, which is 3 squared, equals y squared, or 2 squared, plus the unknown value, which is x being squared, which gives us 9 equals 4 plus x squared. If we subtract 4 from each side, we'll get x squared equals 5. And now we can take the square root of each side to get x equals plus or minus the square root of 5. Now we have to decide, do we want the positive or the negative value? Notice this side is on the negative x-axis. That means we want the negative value for x. And with these 3 sides, we now have everything we need to find the 6 trig function values. So we have sine of theta, cosine of theta, tangent of theta, and their reciprocals, cosecant, secant, and cotangent. So with this, finding sine, it was already given to us, but it's not a bad idea to use the triangle we constructed to make sure we did this properly. So using this triangle, remember sine is y over r, that's 2/3, which matches what we were originally given. That's a good start. Now cosine is x over r, which is negative root 5/3. And tangent is y over x, which is 2/negative root 5. But we can't leave a square root in the denominator, so we'll multiply the numerator and denominator by that square root to cancel it out, since the square root of 5 times the square root of 5 is just 5. And then we have 2√5 in the numerator, and then it's important not to forget that negative. We move it up to the numerator since we can't leave a negative in the denominator. Now we take the reciprocal of all 3 of these. 2/3 for cosecant is going to become 3/2. Cosine, turning to secant, will give us negative 3/√5. Same problem we had with tangent. We need to get that square root out of the denominator. So we'll multiply the top and bottom by the square root of 5, which gives us negative 3√5/5. And for cotangent, we flip this over. Now, rather than flip over this very complicated value we simplified for tangent, go back a step. 2 over negative root 5, let's flip that over to immediately just get negative root 5 over 2. You'd get the same thing if you flip this over and do a bunch of simplifying, but there's no need. Make it easier on yourself. So these are all 6 of our trig function values. Now we just need to clean it up. Let's just rewrite this. Sine of theta is 2 over 3. Cosine of theta is negative root 5 over 3. Tangent of theta is negative 2 root 5 over 5. Cosecant theta is 3 over 2. Secant theta is negative 3 root 5 over 5. And cotangent of theta is negative root 5 over 2. And these are the 6 trig function values of our angle theta based on the following information.